Welcome to a presentation for analysis of world happiness. This is for data mining course, course number CS5593 in the summer of 2021. This was completed by the group of Brian Kiefer, William Liu, and Gabriel Fisher. So, what we're going to cover today is basically introduction to world happiness and the data set that we're going to be using to do some different analysis. We're basically going to be running three different data mining algorithms, including linear regression, k-means clustering, and LOF outlier detection. There's already been some work done in some of these areas regarding happiness, and we'll take a look at that well as in our related work section. And we'll also validate each of these algorithms, come to certain conclusions, and discuss what we could do further. Then we'll also show you the application that we've put together that basically runs each of these algorithms as a separate function once you provide some input and hit the submit button. So let's go ahead and get started. So really our objectives here is to discover, number one, why does happiness even matter? What is causing happiness? Why different nations are happier than some others? What may cause individual happiness? But overall, we want to get an understanding of what separates nations' happiness levels and how can we predict a nation's happiness level over time. So in order to move forward with these goals, we're going to have to basically discover the contributing factors to happiness. And we've got a pretty nice data set that's provided by the World Happiness Organization. And so that data set is going to allow us, it puts a numeric value to a lot of numbers like GDP, freedom, life expectancy, a lot of different variables that can help determine your happiness level. And then we're going to identify, compare, cluster different nations together based off their happiness level and also different levels of these other variables as well. So, give a quick introduction to the World Happiness data set. So, there's two data sets that we're actually going to be working with. Both of them are pulled from Kaggle. One data set, well, they are both derived from the same sources. However, one data set includes 11 years worth of data. So it dates back all the way to the mid-2000s and runs till 2020, whereas we also have the most recent data set, which is of the year 2021, and that one has some additional variables scattered throughout the data set. But you can see Life Ladder here is our main happiness value, whereas a lot of these other variables like GDP, social support, healthy life expectancy, freedom to make choices, generosity, perception, positive affection, are all basically input variables to help us predict our life ladder value. And you can see on the 2021 data set, which is the lower data set here, there's additional data as in the region that you're looking in. It provides standard deviations, upper whisker, lower whisker of your ladder, of your life ladder. So a little more information there to work with. Basically, it's already performed some feature engineering for us. So, as I discussed earlier, there is some related work that already exists out there, and happiness is pertinent in improving society. So there have been several studies done regarding happiness, and the World Happiness Report is the biggest source for that data. A couple of the popular reports out there has been studies on religion, how that is related to happiness. Now that is one thing that is not covered in this data source, is there are no statistics on religion. So that would be interesting future work to think about. The income has been linked to individual happiness, and you'll see throughout this report that GDP, which is a nation's basically, it's a measure of a nation's economic power, is also linked to happiness. So income, finance, is definitely linked to happiness, and there's been many reports regarding that. And then one key focus of our related work is most of these reports all focus on developed nations. So luckily in our data source, we have data for first world, second world, and third world nations. So for our proposed work, basically we're going to be running 3 different algorithms on our data set. We will be using linear regression with the goal of putting together a predictive model used to predict outcome variables, and that outcome variable in our case is life ladder. We'll also be using k-means clustering, and that is to cluster different similar nations together based off the different variables that are contained within that nation. And then we will also be doing a LOF outlier detection system, and that will help us identify either utopias, places that you would love to live in that other nations should model their system after, or dystopias, somewhere where you may not be too happy. So we will be going over each of these algorithms, and we'll talk about model comparison, each of them, go over the validation scores, and go over conclusions that we made in each of these algorithms. So we're going to go ahead and start with linear regression. So the linear regression model helps leading experts across many different fields to make predictions about specific outcomes. You can see the formula here where y is our dependent variable. In our case, we are considering life ladder to be our dependent variable. X is our independent variables, which may or may not have correlations with each other, but they should have correlations with our y variable. And then BO or B1 are constants, and they are coefficients of our independent variables that will help predict our y variable, our dependent variable. So really this model is assuming a linear relationship between input variables and single output variables, and more specifically y is going to be calculated from a linear combination of input variables. So when there's a single input variable, the method is referred to as simple linear regression. When there's multiple, it will be considered multiple linear regression. In our case, this is multiple linear regression. So before we create our model, we needed to understand what the relationship was between each variable, each dependent variable, and our dependent variable life ladder. So we identified our 5 variables with the largest correlation, which would be GDP, social support, healthy life expectancy, freedom to make life choices, and positive effect. Now, in this case, negative correlations would also be just as important. However, you can see on our scale, we do not have any highly negative correlations. And it's important to realize here that GDP is our largest correlation with life ladder. Because we only have a certain number of variables, it was kind of easy to draw out these correlations. However, if we had a high number, we probably would have wanted to use PCA, dimensionality reduction techniques, to get a more manageable dimension on our data set to relate back to our life ladder. So once we build our model and we select certain variables that we are going to calculate coefficients for, how are we going to validate that these independent variables are indicative of our dependent variable? So there's a couple different validation scores that would be used. One would be R squared, which is basically the calculation of sum of squared of the prediction error divided by the total sum of the square. Basically, if R squared is 1.0, that means there's a perfect correlation between two variables. If R squared is a 0, that means there is no correlation whatsoever. There's also our MSE score. So that's your sum of square prediction error minus your predicted output divided by the number of data outputs. And what this is really telling us is the error from the mean. It's sometimes used more commonly than our MAE. But it's probably easier for interpretation than our MAE. And the MAE is kind of the same thing as our mean squared error in the first place. The only difference would be is instead of squaring our prediction error, we are taking the absolute value. So those values should be very similar, but it's a way to double check that we are calculating errors correctly. And so since this is an error calculation, the closer it is to 0, the more accurate our model would be. Now you can't just take your MSE, MAE, and R squared scores as is. They're all relative to model comparison. So let's go ahead and take a look at each model that we developed and designed and see what our scores were. So we basically did tests on 3 different models. Model 1 used all the variables that we discussed earlier in our data set, fed all the variables through our linear regression algorithm, and got pretty solid R squared score, pretty solid MSE score, pretty solid MAE score. So that's pretty decent. But we also threw variables in there that probably didn't have the greatest correlation in the world. So model 2 was a bit more focused on variables with correlations. So we threw GDP, social support, life expectancy, freedom of choice, and positive effect into our model. And we got improved our R squared score, lowered our error score. So that's great. Model 2 is actually the most positive model here, because if you look at model 3, the only thing we fed was GDP, which was our independent variable with the highest correlation to life ladder, and we got some comparatively not so good scores. So in conclusion, linear regression model produced an accurate model. The variables that were chosen were in fact key drivers and really are the drivers for happiness across the world. Overall, GDP was the largest driver. We're able to predict this using linear regression so easily because there were no numerical data points. However, the way this report was put together put perspective on things like social support into a numeric value. In most cases, it wouldn't be so easy, so we are relying heavily on the way this report is collected and the calculations up front. So for future work, it would be probably behoove us to allow a user to use our application and provide different inputs. Right now, we only allow the input of 5 different variables. And you have to fill out all 5 of those variables, so you need that knowledge up front. In the future, it'd probably be better if we allow the user to only basically input what they know, and we can make a prediction from that.
In charge of the clustering algorithm section of the project. My algorithm is k-means. It is a clustering algorithm. It works by randomly generating k points called centroids, and all points in a dataset are assigned to the closest centroid, and those points around the centroid make a cluster. And then afterwards, centroids are adjusted based on the mean of the cluster points. The points are now reassigned to the closest cluster after closest centroid after they've been recalculated, and this process repeats until the clusters stay the same. It is possible in k-means, however, to have an empty cluster, and there are many ways to fix that. My way is just to randomly reassign values to the initial centroids and start over again. This is the dataset I'm using. The overall dataset, it contains two CSV files, one that is pre-2021 data and one that is only 2021 data. My clustering algorithm is built to work on the 2021 data. So as you can see, there are multiple columns such as country name, region, data score, and my algorithm only clusters the numerical ones from columns 3 through I think it's around like 19. And after I ran my algorithm on it, here are the results for happiness score of 3 clusters. Here are my k=3 results for GDP. And here's my results for 4 clusters based on freedom to make life choices. And based on these experiments and other runs I ran off screen, it seems that countries in the same region tends to have similar happiness, as well as closeness and other variables like I shown in GDP and freedom. And countries in regions like Western Europe and North America tend to have higher happiness, while regions such as Africa, the Middle East, and South America tend to have low happiness. Thus, we can somewhat conclude that if we had an imaginary country in a region, we can estimate its general happiness based on the happiness of its geographic neighbors. And I'm going to do a live demo. The clustering algorithm part is these 3 parts right here. This part is the anomaly detection, and this part is the linear regression. So let's set k to, I guess, 3. Let's say we want to do a cluster on the standard error. So that will be the 4th column. And yeah, here we go. Yeah, I mentioned before that the algorithm cannot run clustering on country name or region because they're not numerical. So do not put in 1 or 2 for the variable, or the algorithm will not work. Let's do k=5 for life expectancy. So life expectancy is 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 7, 9. And here it is. So there is my demo of the clustering algorithm.
Okay, I will start talking about my section of the World Happiness Report project. My data mining algorithm, or data mining assignment, was to do anomaly detection. The algorithm that I've used here is local outlier factor, which is a density-based approach. It measures how far a point is from the nearest cluster. You take you use whatever distance measurement you're using. For me, it was Euclidean. You use this to get the distance from everything, but you take the reachability distance, which means that any point that's within the k value for the nearest neighbors you're using for the algorithm will have its distance marked as the distance to the farthest out of the k nearest neighbors. And so you use the reachability distance, and then you use the inverse of average reachability distance to find an LRD for each point, and then you use the LRD of all the neighbors of a point in order to find its local outlier factor. So for the proposed work, we can note that in the World Happiness Report data, there are various trends that hold up that have already had plenty of analysis done, such as wealthier countries being happier, etc. But what I found interesting to look for in this data was to try to find outliers, which might be countries that have unusual statistical profiles or happiness rankings based on those profiles or such things. For instance, if you had a country that was that had nothing but good rankings in lots of the various quality of life measures that are recorded by the report. If you had a country that had very good rankings in all of those, but the citizens tended to be very unhappy, that might be interesting to see why that. So that we could try to figure out in different work why that is. So for the experiments I ran here. I used this algorithm on both the 2021 data set and the data set that included all previous years. And in order to pre-process the data, non-numeric columns such as the name and the name and the region or year, and then rows with NA values were removed from the data in order to make sure that the algorithm runs properly. Okay, so for the 2021 data set, the LOF algorithm was run for k equals 2, 3, 4, and 5. And here in the report, I included some notes about the countries with the lowest outlier values as well as the highest. But the high outlier values showed somewhat more stability here. For all values of K 2, 3, 4, and 5 here, Singapore had the highest outlier score and by a significant margin over the others. But there were other very consistent high scoring countries in the local outlier factor rankings, such as Afghanistan, Haiti, Jamaica, and Rwanda. And then for the dataset including all previous years, I again ran the outlier for K equals 2, 3, 4, and 5. Possibly because of the very large size of the data set relative to the previous one, the results weren't quite as consistent. There was more change in the top rankings when I changed the K value, but there were still consistently appearing data points. The most consistent outliers are Luxembourg 2013 and Greece 2013, which both appeared in all tested K values. The various data points regarding to years of measurement for Singapore appear for K equals 5, which is interesting because there's possibly a connection here to the 2021 results where Singapore was the largest outlier. So for conclusion, it seems that the LOF algorithm worked well on the data set and found some interesting outliers for future study. Singapore was a clear outlier in the 2021 data, but it also appears multiple times in the other years' data with some previous years' measurements. So this might be worth examining further. The country of Singapore might be unusual for its performance in the World Happiness Report rankings in some way. Also worth doing would be to run the LOF algorithm for other years individually, because as it was done here, all years prior to 2021 were included in the same data set, and so various years' data were being compared to each other as well as other years, as well as to other countries' observations within that year. So running it on years individually might help clarify some of the data For instance, if there's if some years happen to have more uniform data than other years, they might be excluded from appearing on the all years at the same time data, but there might still be outliers within those years that would be worth examining.
So we're going to go ahead and run a demo of our application. So the first part here is our linear regression predictive model, where we can input different variables, hit the submit button, and get an output of predicting our life ladder value. So let's go ahead and do something. Now we'll have to put realistic numbers in here. So GDP per capita is 7.15. Social support, let's call that 0.5. Healthy life expectancy at birth, let's call it 82. People are going to live long in this nation. Inner freedom to make life choices, let's say that's 0.75. Let's make it pretty large. And then positive effect, let's just make that 0.45. So we've got all of our inputs. Let's hit submit, and that gives us a value of 4.037049. So because this is linear regression, there's no really rounding off. Basically, we took these inputs and made using our mathematical formula, using the coefficients previously calculated when training our model, we were able to output a life ladder score of 4.0370. And if you compare these numbers we inputted to similar scores, you'll see a life ladder number much the same. So for our k-means clustering algorithm, basically what we have here is inputs for k, and then also inputs for our different variables. So not much input here, but what this is going to do is cluster our nations together and provide an output, basically assigning each nation a specific cluster. So let's go ahead and say k is 3 and a variable of 5. Submit that, and you can see here, this outputs a list of nations and what cluster they belong to. And then finally at the bottom here we have our outlier detection, our LOF outlier detection algorithm, where we have the option of either selecting the year 2021 or our data set that has multiple years. So let's just keep with 2021 for simplicity's sake of this demo. Now this is outlier detection. LOF is also a clustering algorithm, so we're going to provide k for the number of clusters and see if anything falls outside of that cluster, and if it does, then that would be considered an outlier. So let's hit submit, see what we get here. So these outputs here may indicate specific outliers. Basically, any of these values that are outside a specific range, we can compare these values, and that will give us basically nations that are in fact outliers. And that is all we have for the demo.